Alrighty. Hey folks, here we go. Hey everybody. Today we are covering BACnet MSTP. So welcome to Smart Buildings Academy, episode 26. My name is Phil Zito, the founder and CEO of Smart Buildings Academy, and I'm going to be taking you through BACnet MSTP. We're going to take a look actually at BACnet from one of my previous courses. So let's go and switch that over. How is the sound coming through, by the way? Looks like it's pegging on my screen, but let's take a look. Oh, no, it's doing good. Okay, cool. All right, so if you are seeing my screen, which you should be, what I want to take us through today is BACnet master-slave token passing. All right, so MSTP, as it's called, is one form of the BACnet protocol, okay? So BACnet in and of itself, really, there's multiple forms of the protocol, but the only two that matter are IP and MSTP. Now, master-slave token passing is going to utilize typically 3-conductor wire, and that 3-conductor wire is going to be connected from controller to controller in what is called a daisy chain methodology. We'll get to that in just a second. But master-slave token passing, right? It's a common field bus protocol. We use it all the time. And it connects BACnet nodes, which, if you don't know, BACnet objects, the device objects, are known as nodes across physically wired segments. So BACnet MSTP is going to go and enable us to have these controllers communicate back to a supervisory device, which then is going to be able to visualize the data from the BACnet controllers. Okay, so I'm going to just skip ahead a little bit here, and let's go in here. All right, so when we look at MSTP, there's several differences between MSTP and IP, and we're going to cover IP in the next SBA TV episode. But essentially, the main traits that we want to focus in on, that we're concerned with, are going to be the wiring, right? That is going to be one of the biggest factors on whether our MSTP actually works, and the line resistors and addressing. We'll dive a little bit into repeaters and master versus slave capabilities, but we're not going to go too deep down that rabbit hole. For wiring, we follow the RS-485 standard. So for those of you who don't know, MSTP is a serial bus network, and it utilizes RS-485, which is basically a wiring standard. It's typically a 3-wire wiring standard, like 18.3, and it's typically shielded. So the length requirements, the speed requirements, the node count requirements and limits, those are all dictated by RS-485. Then we have MAC addresses, and MAC addresses are the format of addresses for the physical aspect, the layer 2 aspect of MSTP. Now, they are not the addresses necessarily. I'm actually going to lower my desk here while I talk. They're not the addresses necessarily of BACnet devices. The actual address of a BACnet device is the device ID plus the physical address. But they are the physical address of the BACnet device. They have to be unique for each device on that particular field bus, whereas, a device ID has to be unique across the entire BACnet network. The physical address, the MAC address, only has to be unique across that individual field bus. And then there's repeaters and end-of-line resistors, which keep the signal from reflecting and causing all sorts of interference and collisions. I'll fast forward a little bit here, kind of skip through some of this stuff. All right, let's talk through addressing a little bit here. So addressing, in the past it used to be done with dip switches. Nowadays they finally figured out, hey, maybe we should put this in the controller to make life a little bit easier. There's kind of 2 schools of thought on that, right? So you can put it in the controller and have it be done by software, but then you don't have a visual representation of what the address is. But if you have it done by hardware, people who can't add are going to have a little bit of challenge. essentially we can see right here we can just flip dip switches and they add up. So 1 is equal to 1, 2 is equal to 2, 3 is equal to 4, and 4 is equal to 16, and 5 is equal to 32, and then you get kind of how it goes, right? It adds up. I may have skipped a number there. But what you're seeing here as you add these up is that this is called an 8-bit array, and they add up to an address. Now, master addresses, the ones that we really usually care about, are going to be 1 through 127. Those are the addresses of our controllers. 128 through 254, these are slave addresses, and they allow us to have slave devices. And hey, James and Joseph, good to see you here. So they allow dumb devices basically to be added on, usually for monitoring only. Remember when we looked at BTL and we looked at initiators versus executors of services? Well, this is kind of where these things can be executors of a service typically, but they're not going to be initiators of a service. They're like dumb devices that only feed out data. Things like sensors, etc., right? All right, so as we fast forward a little bit more, we go back to the MSTP physical requirements. We can see a little bit here, and we're going to skip forward to speed, also known as baud rate. So this is another area people hose up. So like I said, they hose up the wiring. They cross polarity, which means they wire the positive to the negative or negative to positive. They do T-taps instead of doing daisy chains, which means, if you were to look at it, and I'll bring it up real quick, a T-tap, so, controller to controller to controller, that's a daisy chain. T-tap would be like this. Oh, we're going to add a controller because it's close. And then that causes all sorts of issues with your ring or your daisy chain and passing the token. It just makes things all hosed up. So mismatched baud rates are also a damaging aspect to network communications. With MSTP, your two supported baud rates in the BACnet protocol are 9.6 and 38.4. So those are the only two that are officially supported and required for any BACnet device. Anything outside that is not guaranteed to be supported, although it usually is. Now, that being said, you want to have the same baud rate. We talked about this in troubleshooting like 10 episodes, I think, ago. And the issue with not having the same baud rate is it causes communications to be too fast or too slow, and then you have missed messages. This will indicate itself as a lot of dropped messages or delays between messaging. Okay, so we keep moving along, and skip kind of addressing here. Let's keep moving forward. I'm going to skip over repeaters and move to end-of-line resistors. Alright, so end-of-line resistors, they are 120 ohm resistors that are applied across the positive and negative conductors. They can be dip switches on controllers as well. And what they're meant to do is induce resistance to dampen the signal, because with BACnet being an electrical signal, and this is why MSTP can continue to communicate even though the controller's powered down, because the electrical signal continues to pass through the terminals. With the end-of-line resistor, what happens now is you actually go and dampen that signal and you keep it from reflecting back. So that way you don't get signal interference. Problem with doing that naturally is if you put an end-of-line resistor somewhere in the middle of the trunk, if we went back to our drawing here, ignore this, ignore that. But if we put our end-of-line here instead of here, then we would lose this controller because electrical signals can't go through resistive dampening stuff, right? End of line. So that becomes a problem. Alrighty, let's continue to move on. Once again, I'm going to skip repeaters. We'll skip master slave here. Okay. We'll skip over frames. Like I said, this is from our BACnet Bootcamp course, so as you would imagine, it goes much deeper than this episode does. But realize, let's go here because this is ridiculously complex. But essentially what happens is we see, right, we've got initialization, then we've got idle, and then the controller waits for a token. If it gets a token, great. If not, it just waits for a reply. If it does get the token and it's got something to do with it, it's going to use the token. This is the state model for how MSTP communication works. So, right, it's idling and then it receives the token. It uses the token. If it's done with the token, it will go and hand off that and then pass the token to another controller. So you can kind of see how this all works. This is important to know if you're doing actual integration and design. I'll be honest, I've never really had to use this from a troubleshooting perspective. It's just kind of cool to know if you're actually getting into writing BACnet stacks, which, let's be honest, most people aren't. So let's continue along here. We can see some baseline communication of MSTP. You can kind of see how it works, right? You got the BACnet application protocol data unit, and we see a read property. It's reading the property of object list, so we can kind of see how this is. We see that it's a confirmed request, and then we've got our complex acknowledgement, which means that it's sending an acknowledgement back along with the data requested, because read property has a complex acknowledgement for the service. So we can kind of see how all this works. And then, right, we can see a basic example of setting up communication within Niagara and then going and doing a little bit of consumption. That being said, that's the basics of BACnet MSTP, kind of high level. Pretty straightforward, not terribly difficult protocol. A lot of people tend to mess it up because they don't understand the baseline requirements of unique address, unique device ID, same speed, protect your end of lines, only use them at the literal end of line, and don't cross the polarity of your wire, and don't change wire types. So if you follow those, you will almost never have a BACnet MSTP communication issue. All right, with that being said, let's take a look at what questions you all have. So, what questions does anyone have about BACnet MSTP? Alrighty, I'm going to transition us back to video. Woohoo! You see my smiling face. I'm going to exit out of that video. All right, let's see. If you did have a question about BACnet MSTP, what would that question be? Recently found your podcast and I cannot stop listening to it. Been doing this for 7 years and still have a ton to learn. Made it to episode 48. My friend Joseph, it gets much better. Because if I'm totally straight with you, the first 50 episodes, I was so uncomfortable. Like episode 1, I'm like, this is Phil's, welcome to Building Automation Monthly Podcast. I'm like I was so freaking nervous. And now I just hop on and I'm like, hey, yeah, all right, let's just, let's get this done with. Because, after you've been doing 200 plus episodes of them. That's really good. So, yeah, there's so much stuff there. I really hope you're getting some stuff from it. If you ever have any questions, Joseph, man, we're super responsive. Just hit up the comments, whether that's through YouTube, whether that's through the podcast. That reminds me I need to upload a lot of the newer podcasts to our YouTube playlist. Thanks for reminding me for that. I'm going to take a sticky note on that and get my team on doing that. Upload SBA to podcast list. Okay, got it. But yeah, that's one of those things, it's like there wasn't really good content out there and I just didn't like it and still isn't. Like if I go on LinkedIn, it's all just self-promotion and just our product and our company, and ooh, look at this panel I built, it's so cool, I can make stuff look perfect. And I'm like, okay, go do that on the actual job site when someone's screaming at you to bounce between job to job to job, and actually have the time to do that in the real world. But I digress. Man, I am getting ornery in my old age, like becoming a grumpy old man. But anyways, so yeah, Joseph, if I can ever answer any questions for you, let me know, buddy. Just feel free to ask. I love doing this stuff. I love engaging with people and answering their questions. I think we're probably going to move back to the 8 p.m. We don't get as many people during the daytime. Maybe we'll do morning. I think we'll do morning. Because I moved to the 11 on Mondays or on Wednesdays because I wanted to give the European folks time to hop in, and the Asia Pacific area. But maybe I'll move to like early morning our time. Let's see. Any other questions from anyone in here? Feel free to ask. Don't be shy. I will encourage you, if you haven't and you really like the podcast, Joseph, go into iTunes and leave a review and a rating. It really helps get eyeballs and ears on the show. Okay, not seeing any questions. So what we'll do is we'll call it. I will go eat, and then I got a webinar to do. Woohoo! I'm going to be running through. You know what? I will show you all. This has been like, seriously, this webinar. I wish I'd done it sooner because it is absolutely been amazing, this webinar here. Let me pull it up and kind of show you all. You mentioned using VLANs instead of BBMDs. How do you make devices communicate across subnets without BBMDs? Well, you don't. So a VLAN is a subnet, right? So let's go through this here. If you're going to have multiple VLANs, then you still need BBMDs, right? So we've got a physical LAN with devices. Boom, device, boom, device. And then we've got another physical LAN. Device, device. And we'll say this is subnet 1, this is subnet 2, this is subnet 1, this is subnet 2, this is router, and this is router. Each subnet is or each VLAN, not subnet, I meant to say VLAN. Replace subnet with VLAN. V, okay, we're doing that. V, and V, right? And this is 2. I don't know why I made it an N, but that's a sideways 2. So, right, if you got VLAN 1, that essentially, so that physically looks like this. Logically, it looks like this, right? VLAN, VLAN. I'm not drawing, so hold on here. Oh, I do this all the time. There you go. Here we go. So VLAN right here, VLAN 1, VLAN 1, VLAN 2, VLAN 2, and VLAN 1 would actually look like this right here. So that is how you make them communicate. Because if they're on the same LAN, then you don't need the BBMD to do the broadcast. Because remember, there are only 2 services that you need the broadcast for. And that is the who is I am and the who has I have. But once you've established the who is I am and you've built your BACnet list, so you've like built a backnode list, so this is an array of your BACnet nodes, and you've built that list, then all of your who is I, or all of your read property, write property, etc., all of those services are going to use the BACnet virtual link and the NPDUs and APDUs to send unicast or multicast messages to BACnet devices. So you only need the who is I am or you only need the BBMD and BDTs for who is I am and who has I have. Once that discovery, and who is I am is device discovery, who has I have is object discovery. Once you have done that, then and you've built out your back node and you've built out your object nodes associated with that back nodes, then you are going to not need the BBMD anymore. I work for a campus where we have over 200 BBMDs and we're trying to reduce the number. We're fighting with IT to get us a VLAN set up. Yeah, that should be a significant reduction once you get that VLAN set up, because then broadcast cannot traverse IP boundaries. So they cannot traverse subnet boundaries. So if you ever kind of want to know collision domain versus broadcast domain, okay. So a collision domain is a set of devices in which a packet collision could occur. A broadcast domain refers to the logical set of reachable computer systems without a router. So you are concerned with what is called a broadcast domain. So if we go in and we look at the images here, right? This is a collision domain. This is a local area network, right? This is a broadcast domain. We're not concerned with the collision domain. We're concerned with the broadcast domain, because the broadcast domain is where our BDTs and BBMDs need to be. We need to have one BBMD with a BDT, which is BACnet distribution table, with all of the entries for all of the other broadcast domains that we need to write to. Does that make sense, Joseph? Hopefully it does. If not, I'd encourage you to check out our BACnet bootcamp. But that's the simplest way, right? So are you telling me you have 200 separate VLANs? Or 200 separate LANs? You have like a LAN per building, I imagine, and then you have a BBMD for each building with a BDT? I've got to imagine that's what's going on. It's like a separate LAN with each building automation. Or with each building. Which is normal. So, yeah. But that would that's not going to reduce the broadcast traffic, though. Let me be clear about that. You will still have quite a bit of broadcast noise as you consolidate those BBMDs. So the reality is you have to balance, like, maybe one VLAN per building. And that would make it a little bit more manageable, because now what's going to happen if you make a large VLAN, because most likely you're not going to be able to use a /24, which would give you 254 addresses. Most likely you're going to have to use like a /22, which will give you 1,026 addresses. When you expand that, that now makes a much bigger IP pool that you need to manage. There's going to be a lot more discovery crosstalk, and it's going to be more difficult to troubleshoot. So it's kind of a delicate balance of going and laying out that strategy. Alrighty. Okay. What do I got going on here? What is that? Oh, never fails. Things blowing up left and right. We are streaming live. People messaging me and going, "Where are you? I don't see your stream." You need to hit subscribe and hit the notification bell, and that will make sure you get it. It'll pop up on your phone or wherever your YouTube videos are consumed. And we're going to be standing up an app pretty soon that is going to make all of this much easier to access. So Joseph, that helped kind of my explanation. It's not like I wouldn't recommend setting up a single VLAN for all of BACnet, but even if you did just one VLAN per building, that would still reduce the amount of BBMDs you have. So hopefully that helps. Yeah, I get it. That is. You know what? Honestly, though, the most valuable thing you can do as far as pure operational efficiency is come up with a naming standard. Like, come up with a naming standard that you implement. Haystack has a good naming standard. Cornell has a good BAS standard that you can copy, and create a naming standard and start applying that to your HVAC systems. By doing that, you're going to make it to where you only have to train people once, and then they can go to the building and everything's going to be named the same. It also makes it much easier to train your tenants if you're using any tenant-facing applications, because all the points are going to be the same. That's like, if people ask me, like, what's the single most valuable thing I can do in a campus environment? It's a naming standard. After the naming standard, it then becomes a sequence and trending standard, and then an alarming standard. Those three things will massively increase your operational efficiency, because if everything is sequenced the same and everything's named the same and graphics are the same and your alarms are the same, then you only have to train someone once on a specific system, and then you can go from building to building to building, and it's relatively easy because they're all the same systems. You hear all these people who are all system integration this, smart building that, all these tenant-facing apps. None of that shit matters, pardon my French, if you go and do not deal with the operational stuff up front. You're going to get your biggest impact from operational efficiencies in a campus environment. Now, if we're talking a single office building, that's completely different. I'm not talking about single office buildings. I'm talking about a campus environment. When you go into a single office building, your strategy there is completely different because you may be using outsourced labor for your operations. Alrighty. Let's transition. I feel like I'm missing something. Okay, so let's talk about what to expect coming up. So, SBA TV. I'm going to actually share this real quickly. We're going to take a look at what's coming up. SBA TV. So we are at, oops, they're not going to be happy if I do that. We are at part 2 right now of SBA TV. And so then 3 is going to be IP. Then we're going to look at HVAC space control on the 17th. We're going to do 3 not live sessions because I'm going to be on vacation. We're going to do psychrometrics, airside system, and pressure control. Then we're going to roll into chilled water, hot water. We're going to talk about performing takeoffs, and we're going to do point-to-point checkout. I am open for ideas on the month of April. If any of you are wondering, I may actually call owner integration management. I think that is a cool topic. So yeah, let's take a look. What else could we do? Owner integration management. Retrofit scoping, maybe? The pro and con of having the experience background I have is that I could talk about almost anything, but I can talk about almost anything. So that can be a con at the same time too. Owner integration, retrofit scoping. Oh, what else? What else should we talk about? Cybersecurity 101. Like, that is something everyone's asking me about. Cybersecurity 101. Touchless strategies. Ooh, that's a cool one. I'll probably do a podcast on that. Like, how do we do touchless strategies? People who are tuning in like right now are like, what the hell is this dude talking about? I thought this was BACnet. You got to be on time to get the BACnet stuff. So, all right. Touchless strategies, retrofit, cybersecurity, owner integration, point-to-point checkout. I can't think of 40. I'll think of it later. All right. What is going on? No, cancel, exit. All right, there we go. And let's transition back to Phil Zito here. Good stuff. All right, well, that being said, if any of you have any questions, hit us up in the chat afterwards. Thanks a ton for being here. Super awesome to have you. As always, make sure you subscribe and hit the bell icon to get notified. That will help. With that being said, we're going to call today's video, and I will see you all on Monday at 8.